So here's a second example of method of joints. It is the exact same process, but of course it looks a little different because it is attached to a vertical wall, but go through the same steps that you would on any other truss. First thing I would do if I were you is identify the reaction forces in the pins, those support forces. So my first instinct is always to go up with one of the forces at the pin and to the right. It's just a default. If you're wrong, then the arrow just points in the different direction. Not a big deal. One thing to notice about this roller on the wall is that, again, the reaction force acts perpendicular to the surface that you're attached to. So in this case, it's going out to the right, so I'm going to label it with an X coordinate. It's not going up, it's going to the right. And this is a little hint on what you should do. And of course you have the two other exterior forces at B and C. So what I would do is you can do a quick outline of what the forces are and where they are located. And here's what I would do, although first, my apologies, I'm jumping ahead of myself. Let's find out what those reaction forces are. And so the way I would do this is take a look at point D and A, and you can outline the others, E, B, and C. But the important thing here is to note that we have forces acting, 5 different forces acting externally on this truss. And so we have to figure out where to put our moments about. That's usually our first step, is the sum of the moments about a certain point. And so we have 750 acting down at B and 500 acting at C. So as we've done in the past, the most, I think, convenient way to start is some of the moments about D, because that has 2 reaction forces at it already. And if you choose that point, then those 2 forces do not create a moment. They become 0, and that allows you to eliminate the unknowns right off the bat and try to find out the other unknowns. So we have to figure out, we have A of X, 750, and 500. They are creating moments. So we have to figure out where those forces are acting, or how far away from the pivot point they are. And looking at our diagram, each of these is 1 foot. And that's what I mentioned down here. So we're going to go feet and pounds just to mix up the units a little bit. So if I count the squares, A of X is 5 feet. And what I need to look at is the line of action of 750. And so 750 is 5 feet from the wall, from the left wall. So that is how far away from the pivot point it is. And so I'm going to try and draw this as clearly as I can. So this is 5 feet from the pivot point. Remember that we're trying to look at the line of the force. So you can draw the force vertically in this case, up and down. How far horizontally is it from D? If we do the same thing for the 500, we see there's 5 plus another 3, so 8 feet away from that pivot point. The next thing we got to do is figure out which ones are positive and which ones are negative. And so if we look at A of X, and the A of X is trying to pull to the right. And if you locked it in at that point D, it's going to rotate in that direction. Well, that rotation is in the clockwise direction, counterclockwise. So that's a positive rotation, which means the others are trying to rotate in the opposite direction. So both of those are negative. So if you follow your fingers in the direction and curl around the pivot points, you'll see that for B and C, those forces are acting, the thumb points into the page, which is negative. But for A of X wrapping around D, it's the thumb points out. So let's continue the calculation. So I would say A of X is positive times that 5 feet minus 750 times 5 feet. Remember, we already taken into account the negative with that minus. And then 500 times the 8 feet. All of that is equal to 0. So some simple algebra will get you A of X, which is 1,550 pounds. And so since A of X, we originally drew it to the right, and it came out positive, then it's acting to the right. So the original arrow is correct. Now we need to use the other two conditions of equilibrium, which is some of the forces in the X and Y direction. We'll do X first. You see there's really only two forces. We got A of X acting to the right, so that's positive. And we drew D of X to the right, and so we're going to draw that as positive. But you can probably look at it and go, well, mathematically, one of them's got to be negative. And so D of X is equal to negative A of X. So that means it's equal to negative 1,550 pounds, or 1,550 pounds, which tells us that it should be pointing left. And we'll make a correction for that in the next drawing. And now the Y direction. The vertical, there's three of them, vertical forces. We have D of Y acting up, minus 750, minus 500. And that's equal to 0. So pretty simple one here. We get 1250. And what that 1250 tells us, pounds, is that we drew D of Y up to begin with, and so that's the direction that it's actually going. Okay. So now here's where you want to draw a free body diagram at each point or junction. So I'm going to sketch out D here and put A down here. I'm not really worried too much about counting blocks and getting the exact scale. I just want to sketch what I would consider a free body diagram, free of really the numerous details, but just giving me general forces and directions. Okay, let's try. I'd like to draw my reaction or my exterior forces first. And so let's draw them. Notice I'm drawing D of X to the right. And so that's, we know what that is. That's 1,550. So I would say just put that in there. We know that number. So why not put it in? D of Y is acting up. And what was that? 1,250. So you don't need to really bring down the variables with you. If you know the numbers, then plug them in. And then we got 1,550 acting to the right. And then the two other forces, 750 and 500. Now we draw the beams. And so quite a few coming off of D. We have DE. And I always try to draw the matching force coming back the other way, just so I don't forget anything. AD up and down here. And then diagonally across D to B. And then we got EB, EB. And then notice how this one has two forces acting to the right. So I like to draw one after the other. So you don't, if you draw it over each other, you might still be able to see okay, but you want to make sure you don't forget it. And we got BC here. BC there. EC. and EC. Quick glance around to make sure you didn't forget it. You should see the same letters twice. Everything has a pair. Didn't do a good job of thinking ahead and drawing that EB. There you go. All right, so let's pick a point and figure some stuff out. So we're going to look at point A first. It seems to be the simplest, and we can just start the chain or the dominoes falling. And so look, we're doing this digitally. So why not use the technology we have? And voila, no need to rewrite it. And so let's remember, we don't do any moments at these. We do sum of the forces in the x and y direction. Both are still equal to 0. We got AB acting to the right, plus that 1550 equals 0. So AB is equal to negative 1,550 pounds. So that tells us that it's in compression, And maybe we'll do hot pink for compression. So the way that I would write this in there, compression, so 1550 in compression. We got one of them already. And the interesting other result is that the sum of the forces in the y direction equals 0. AD is 0. So there's no forces there. I'm going to draw that in black, just because it's kind of a unique solution there. All right, let's look at D next. I gave a little bit too much room there. And I also copied and pasted it down to here. And so that's a nice way. You want to do that. Otherwise, you're scrolling up and down. It just becomes a pain in the butt. And what I need to do is put in the values that I know. So 1250 up, 1550 to the left. And the other thing that we do know is that AD, or DA in this case, is 0. So, good thing to remember. Did not want to bring that down. All right. So, some of the forces in the x and y direction. And so we need to figure out angles. And what you'll find is that because of the symmetry, the 3 by 3 there, this becomes 45 degrees. And of course, that is also 45 degrees. And if we do sum of the forces in the x direction equal to 0, we have a couple of things. We can look at DE minus the 1550, good so far. And then we're adding the x component of dB. That's dB cosine of 45. So there's the problem, is that is two unknowns. So we fix that by saying, all right, let's leave it and come back to it. Let's do some of the forces in the y direction. We got 1250 acting up minus AD, which is 0. So I'll write it down so you know I'm not forgetting about it. And then minus dB cosine of 45. But honestly, you could do dB sine of 45, and this is the same thing, equals 0. So now we can solve for dB, and we get 1767.8, and that tells us that it's in tension, because we always assume tension, so the arrows that we draw represent tension. And so I'm going to draw tension as green. And so 1767 for dB. 1767 and tension. So we're filling out 3 already. So now we can go back and take a look at substituting that in. Remember, we keep if we have negatives, we keep the negatives. This time we have positive, so we have DE minus 1550 plus the 1767.8 that we just got, cosine of 45 equals 0. And solving for DE, I'm going to let you do that. I think you can handle that stuff. We get 300 pounds, positive 300. So once again, we're in tension. We'll do that in green. And we got that one too. So we're rolling along pretty nicely. What did I get? 300. 300. And this is how I'd like you to label a diagram on the quiz. Or I might have you fill out some lines down here. Okay? But for now, I'm just putting it in the diagram. So fill it out as you go along and stay with it. So now let's go to joint B. There's a lot going on there, but again, we have a lot of information already. We have DB and AB. So we are missing 2 of them. So as I did before, use your technology to make your life easier. Nothing wrong with that. Okay. So let's put in some things that we know, or at least write them down. We know that DB is 1767.8. And then AB is negative 1550. Notice I keep the negative in there. I'm not going to, if you keep flipping stuff around, you're going to lose track of what you flipped and what you didn't. Keep your arrows the same. Write down compression or tension based on that, and we'll know the arrows go in the opposite direction. So keep the numbers, otherwise you're going to lose a negative in there. It's hard to determine whether you did or not. So just keep them in there. So I always say just go sum the forces in the x direction first, and if you don't have enough, then you come back to it. So we got BC acting to the right, minus AB. And then you got minus the x component of DB. Notice that, and if you're still struggling with some of this stuff, we can look at DB and realize that we have an x component and a y component. So when we do that sine and cosine, I need you to get used to the fact that I'm just going to go right to AB cosine of whatever the angle is. It is negative, that's why I have the minus sign. Well, we know that AB is negative 1550. This is one of those cases where you need to make sure that, that is DB. DB cosine of 45, But the negative, see the 2 negatives there make it a positive, and that's something that you might lose if you keep flipping things around. DB we also know, that's 1767, positive, cosine of 45. Well, looks like we have enough information here. We only have one unknown. So if you do everything right, you get negative 800 pounds. So that is in compression. And I think I did a hot pink for that one. That's fine. And I will draw BC as 800 in compression. Okay. Now let's go back and get the other one. This is probably as lengthy as it's going to get for anything, and depending on the scenario, but the number of beams you're going to have to calculate. So let's some of the forces in the Y. We have EB acting up, minus 750. I like to go to the straight ones and then kind of add the angular ones as needed. Then we got positive DB sine of 45. All of that is equal to 0. Remember that DB, the positive one, is going up. X is going negatively. So keep an eye on that. So EB minus 750. We know what DB is. And so we can solve for EB, and we get negative 500. Well, once again, that is in compression. So we go up, we slide up to the main diagram, we look at EB, and we see that that's 500 in compression. And notice the colors. I like the color schemes. Try and do that if you would, and it'll help you and it'll help me look at it and grade. But it just shows you, like, the green is like where they should be, and the compression ones are acting the other direction. But I think it's more important to know the value and just know that which ones are and which ones are not in tension. So if you look at our diagram, actually, there's only one left. Right? You can choose E or C. And so, pick your poison, whatever feels easier to you, maybe. I think C might be less vectors to deal with. So let's take a look at. Paste. Okay. All right, let's wrap this up. We got some of the forces in the x direction equals 0. Now there's nothing acting to the right, so I have negative BC, but I know what BC is, don't I? I know that BC is equal to negative 300. If you recall, we just solved for negative 800, excuse me. Oh, excuse me, that's negative 300. I apologize. I glanced at my work incorrectly. Let me go back and make a small correction there. I apologize, everybody. 300. And I will make that correction up in our main diagram. I was trying to go through this quickly so you didn't have to waste too much time in the video. And a little mistake there, but I was looking at my old notes on it, and my handwriting was not great. So BC is negative 300. Keep that negative. And we are looking for EC. That's all we need. And so we got negative BC is acting to the left, and then minus EC cosine of that angle, which when you take a look at the diagram, which we can do the calculation, you'll find that out to be 59 degrees. If you're wondering how to do that, I'll do a quick look at that. And it's given in the diagram, so that's easy to do. But if you want to do tangent of that angle at C, that's equal to opposite, which is 1, 2, 3, 4, 5, over adjacent, 1, 2, 3. So that's how you can solve for that. So we got negative 300. Important to keep that negative. Minus EC cosine of 59 degrees. So EC comes out to be positive 582.5 pounds. That means you're in tension. That means we highlight you in green or whatever color you see fit. Scroll up to our diagram, and look, if I can see your diagram like this, you're done. And 582.5 pounds. We don't need pounds. I think we all know the units, so you don't need to cram that in there. Just give me 582.5. And we know that that's in tension. So I can glance at that, look around, and know exactly what the answers are. So I'll let you know what I'd like you to do with the answers, whether to put them here or put them here. Okay.